Hello everyone, this is Ayush R from IIT Madras and today we are on our new topic, that is gravitation. What gravitation actually refers to what things it is actually exerted, okay, where the gravitational force is exerted. Whenever there is a gravitational force between two bodies, okay, any object on this planet experiences gravitational force whenever two objects are placed at a distance d or r, say r with a distance. Whenever two objects are placed at a distance r, some force of gravitation is acting between them. Why this force actually acts, we will understand in our further video. So today that's our main purpose, to study what is gravitation. Okay, gravitation is nothing but it's an attractive force. Okay, gravitational force is always an attractive force. The force of attraction means every body is attracted by some another body by the force of gravitation. We will move on further with the universal law of gravitation, Kepler's laws, and further many more things we will be studying in this topic. Okay. In fact, you and me are also attracted by some forces of gravitation. Why? Because we are not attracted that much. Okay, we are not attracted that we are stuck together because of the less magnitude of our masses. Okay, the less is our mass in comparison with Earth mass, that is 6 into 10 to the power 24 kg. The mass of our Earth is 6 into 10 to the power 24 kg. How big this value is? Let me explain you. Add 6 here and after that you have to put 24 zeros. How many zeros? 24 zeros. Up to 24 zeros. How much big this number is in kgs? In kg. Okay. The mass of Earth is this much. And in comparison to this quantity, in comparison with this mass, our mass is just like 60 kg. How much it is bigger? It is approx crores and crores of times bigger number than our actual mass. That's why we are attracted towards Earth. Not Earth is attracted towards us, because the mass of Earth is higher. In comparison with Moon, the mass of Moon is 1/6 the mass of Earth. 1/6 the mass of Earth. That's why Moon revolves around Earth. Not Earth revolves around Moon. That's clear. Mass actually plays the biggest role here. Mass is actually playing the biggest role whenever we are talking about the forces of gravitation. Mass depends. Okay, so what we had studied, the force of gravity is actually depending upon the mass. Mass is the biggest player in this chapter. Now we are moving to our first topic of this chapter, that is Kepler's law of planetary motion. Kepler's law of planetary motion. Kepler's law of planetary motion, what Kepler had stated in his 3 laws. He proposed 3 laws. The first law states that all the planets revolve around in an elliptical orbit. At their respective foci. Say this foci is F1. The length from here to here. Okay. from the center to here and here to here, and this length is f2 from there to there. Okay, so this planet is P1, and consider one more planet P2. Two planets you just consider, say Earth and Mars. Earth and Mars. So this distance from F1 is FP1. Again, whenever we are going to, this distance, perpendicular distance is P1F2. Again, one more point to the planet 2, and this distance is P2F2. So this is the distance between them. Whenever we are talking about planets, this Kepler's law is applicable. What Kepler's first law had stated, all the planets revolve around an elliptical orbit in the shape of egg. The shape of egg is just similar to the shape of ellipse. Ellipse is an mathematical shape, geometrical shape. You will be studying in your higher classes what is the actual geometry of ellipse. It is not a circle, but it's the extended circle. Okay, extended part of circles. You can refer to an egg. Egg is having the shape of ellipse. Next, in his second law, he had stated that the aerial velocity remains constant. All the planets, say P1 and P2, are having the constant aerial velocities. So what this actual aerial velocity refers to? Aerial velocity is nothing but the velocity in an particular area. Okay, velocity of a planet in an particular area. Say del A be the area, del A be the area. Next, del A be the area. What is the expression of kinetic energy? Do you know the expression of kinetic energy? Half mv square. So whenever we are moving, it is similar to the expression of kinetic energy multiplied by the small period of time. The small period of time. So by doing the simple mathematical operation, we will get del A by del T is equal to multiplying and dividing by m, half VR by 2. Do you know this formula? MVR, which quantity arises? L is equal to MVR. L is equal to MVR. It is the angular momentum. So del A by del T is equal to L by 2m, which is always constant, which is always remaining constant. Del A by del T is equal to L by 2m. That is the second law of Kepler. Del A by del T is equal to L by 2m. Second law of Kepler. The first law states that all the planets revolve around an elliptical orbit. And the second law states that the aerial velocity remains constant. And that's the expression for aerial velocity. The third law of Kepler states that some time period of a planet is t. Okay. In an elliptical orbit, again in the elliptical orbit, the planet 1 and planet 2 are having their respective time periods of revolution around the center. So this is the sun. So this is the center, sun. They are revolving in an elliptical orbit. How much time it will take? How much time it is taking on this region